What? No, it's okay. I've got a guide how to get across here. 3 paces to the right for no answers, 3 paces to the left for yes answers. Right, here we go. Is there more than one standard imperial thread? Yes. 1, 2, 3. Are imperial threads measured by the distance between their pitch? No. 1, 2, 3. Are standard imperial thread angles 55 degrees? Yes, of course they are. 1, 2. Oh, hang on a minute. What about William Sellers and 60 degrees? Hello and welcome to Tweed's Garage. Billy, in your bed. So welcome back. What have we been up to? Well, still working on the Riley, doing little jobs here and there, trying to get things right before we get round to starting the engine. One of the jobs to do, I'd taken the nut off, I think, when I was taking the steering column out. There's the drop link from the steering box down to a steering connecting arm, and there's a ball joint at the bottom there. I did try and pop it out, couldn't get it out, and in the end I didn't need to do it. I took the arm off from the steering box, off of the spline. But as I had it apart, put it back together, I was looking at the bottom of the end of the tube, and it's got the screw and a split pin, and what happens is when you take that out, manage to get it out, it was all a bit seized in there, but there's 2 springs, a spring at each end, and then there's a brass phosphor bronze supporting cup for the ball joint, and it just sort of gives a little bit of sort of shock absorber movement in the steering arm. So I think if you sort of go in a pothole or something, so it doesn't jar the steering wheel out of your arm. So got it all freed off, cleaned it out, greased it all up, and then put that back together. So that's another little service job done, don't have to worry about. So I said in the last video I was going to remake this oil pipe for the rockers, but I was struggling to find what this thread was. It was 5/16, and every time I measured it, it came out at 25 threads per inch, which are really weird. There was none in my thread books like that. So I kept looking, and the lathe doesn't have the setting to do it. I think there's a way around it, but in the end there's a company in the UK called Tracy Tools. Some of you may know, very good for sort of taps and dies, no affiliation, just use them. And went on their website and found these 25 threads per inch are what I said I was suspected they were. They're a brass form, they call them, or brass whip form thread. So they're threads for brass or steel going into brass, another magic British thread pattern. And then I phoned them up. Well, I found, because I needed to make new bolts as well, because these are the bolts, but they do look like somebody's used sump bolts. And I don't know if you can see on there, I don't know whether it will show up, but you can sort of see there's a double thread. I'll do a close-up of it. You know, the thread pattern here is totally different to here. So whether that's been wound in to the brass and it's changed it without damaging the brass, I don't know, or whether somebody's run a die down it, I don't know. So I suspect they're not the original ones. So I needed to make some new ones of these, and I was going to reuse this, but because I found I could get taps for it, I made a new one. But it was a bit tricky again. For the quarter, there's a really weird thing with brass threads. You could get, might be wrong, but I think you can get a 24, 25 and a 26 threads per inch whip form brass taps. So it seems like every size they do about 3 thread pitches for. But the 5/16, I think it was something like, it was either 26, 27, 28 or 23, 24, no, 22, 23, 24, but I didn't do 25. So I gave them a ring, and they had the quarter 25s in stock, had those. And they're just sort of cheap Chinese ones. They weren't that brilliant. I had to clean them up a bit, but because they were only using them in brass, it wasn't a problem. But he said, oh, I'll go and have a look. And he went and had a look, and he said, oh, we had some special ones made. So apparently the obviously Douglas Motorcycle Club, had some of these made. These are the 5/16 by 25. So he had a few of those left, so he sold me one of those. that was about 30 quid just for one tap, because they're made in Germany, and then these, because they're made in China, are about sort of 6 or 7 quid each. But yeah, the quality shows when you actually go to use them. But it meant that I could make a new union, and then solder it in, and solder on the sort of banjo oilways on the end of the tubing. Now, I was looking at this and couldn't work out. I just thought it had got bent up in service, you know, where it had been used so many times. A bit of a weird shape. But when I started fitting it up and bolting it on, and working out how to bend the pipe work before I soldered it, so I didn't have to bend it too much once it was all done together, is the magneto gets in the way. So that's why it's a funny shape. I sort of bought it so it will come round the magneto. But yeah, that's why they're an odd shape. So I also turned up 2 new bolts with the corrects, because I bought a die as well. So put the correct thread on for these, because these go into little brass unions that screw in to the rocker covers like that, and they've got a slot on this side, and then the oil goes, and it's got a groove at the top of it, of each slot, so that the oil can get through. What I also done with the unions on mine is this groove that runs on the front, I flipped them over and milled the back, so they got a groove on the back as well. Do a little diagram of how the oil flows round them. There is the possibility that you could these could get screwed in too far and then bottom out on the aluminium at the back, and maybe cause a bit of a restriction. So just to be safe, I'll just put a little groove on the back of them. But normally I think you just wind them in a little bit past the aluminium, and then your bolt goes in, and the bolt, when it goes in, doesn't go all the way in to the oil way behind, so there's a bit of a gap behind it. So I just made sure all my widths and lengths were right, so that should work okay. I struggled to get the right size fibre washers, so I've got some ones with the right internal diameter to fit over the little lip that I left on them, so they stop them sliding around. But as you can see, they're too big on the back, so I put them on a stack of them on a mandrel on the lathe, and turn them down with a really sharp tool, and they turn down really well. So yeah, if you're ever sort of struggling for fibre washers, you know, the wrong size, if you can get the right internal size but bigger, they can be turned down on the lathe. So before I put the copper tubing into the union fitting here, the original one, this one, it looks like once they've soldered it in, it's a complete pipe, and they've just wanged a drill down through it. It's quite jagged and a bit of a mess. So what I done with my one was laid it out flat, and with a sanding disc on a Dremel, just gradually ground it away until I left the back edge so it's still attached together. Then fed that through, and then soldered at each side, and then worked out the bend form on it, and then soldered the other 2 ends. Another little job amongst some of the I bought a load of dial indicators, and there's some micrometers that came with it. I've got loads of micrometers, I don't really use them, but I was looking through them, and there was this one in a little pouch. I haven't got the pouch with me, but it's like an offset micrometer, about an inch offset, but it's really good for reaching through something with a lip and measuring. I used it actually to measure the width of the glass on the windscreen, so it goes around the frame, and then you can wind it on and measure the glass without, and before I strip the windscreen down. So it was in a bit of a state. It was all rusty and looking a bit rough, so I chucked it in my sort of bucket of degreaser cleaner stuff and left it in for a couple of weeks. It's basically just paraffin, petrol, diesel. It's just whatever I have lying around from cleaning, I just chuck it all in the pot, and it seems to work really well. So I stripped it down, gave it a good clean. And pulled out the little stops. There's some little cam stops each end to fix the anvil and to lock your thimble like that. So they were a bit gummed up, so I managed to get them out and clean it, and then I put it back together and adjusted it up, and it works really nice. So that kept us busy. Another little job, not associated with a Riley, it was I've been sorting out some clocks for a friend. These are off of a Mark III Ford called Tina, and what happens is over the years the plastic little knob for resetting the clocks break off, and the threads on the end of the shafts break off. They're tiny. The shafts are about 2 millimeters, something like that, and the thread on the end is like sort of 1.8 millimeters. So to turn something this small on the lathe, I took the 3-jaw chuck off, and I've got quick release collets that go on the lathe, so I put them in, and that grip the rod really nicely, and I managed to be able to turn this shaft down to 1.8 millimeters, and then ran a little die down it, and I managed to turn up these screws as well. They've got like an internal thread. The screw goes on that, and it goes through the knob. It's got a little shoulder on it that pulls the knob down, and it's got a little square, two flats on it, one on each side, which there should be one on the little flat on each side of the plastic knob, but I didn't have the facilities to do that. But it's so small, what I'd done was, once I turned these little knobs up, put the shaft in the vise, and push down with the vise to sort of cut its way on the flats. Yeah, that seems to work really well, and you can adjust the clock now, and it almost looks original. I chemical black them. Also to put them on the milling machine and turn down the backs, because they're square at the back, because there's a little washer that goes on the back with a square hole in, that's sort of pushed on there and then sort of soldered on the back to stop it popping through. It's tiny, but yeah, come out really well. So I made him a couple of spare ones, a couple of spare shafts and a knob, and put a new one on the clock. So something else kept us busy. Also turned down, I had turned some new studs up for the water hose, or the water inlet and outlet, because they had corroded quite badly, and at the time I only had sort of a steel rod the same size, so I turned up 2 new ones, but then I've since got some stainless steel, and so I remade those rods in stainless steel, so hopefully they will last a bit longer. So I've got some stainless steel, and popped them in the lathe, and started using the ANIJEST quick threading gearbox on the lathe. A bit of trepidation to start off with, but once you've got it set up, you've got a little slider, a little bar that underneath, and you've got a little stop that you adjust to where you want it. So it's a bit of a fiddle work getting it to work out where you want to stop it on the rod where you're cutting the thread. But once you've got it set there, it'll always stop there. So you can literally turn your screw cutting speeds up, and yeah, you just sort of pull the lever, let it go, it'll run across, and then bang, it'll just jump out and stop, and you just wind the tool out, wind it back in again to your settings, and set it off along on its way, and keep going until your thread's cut. And it works really well. So I used it to cut a thread on these, an internal thread on these, and once you got it set up, I mean, it's stopping about 0.5 mil before the end. Yeah, it's great. You just sort of hit the lever, off it goes, stop, wind it out, and keep going. Yeah, it sort of gives you sort of a, yes, it gets you a bit nervous, but once you get the hang of it, it's really good. And I made these because these are the sort of rocker cover fixing nuts, but it's got a shaft on the back of it with a thread on, because I made some holding arms for the rocker cover, like the tappet covers. Yeah, I've seen these on a few Rileys, but I don't think the club might make them, but anyway, they're quite expensive. Second hand, they're extortionate. So I thought I could make some. So I made these on the lathe, and then on the milling machine, and then turned up some nuts to go on the top of them like that, and then they look quite good once they're in place. Got to remake these. I've put the shoulder on the wrong. I wasn't concentrating properly with the mill, and I've put the shoulder on the wrong piece of it. But I'll make a new set. But to make them was a bit of a challenge, because they're sort of, everything sort of sweeps down at an angle that way, and then down that way and that way, and it was sort of holding it and trying to sort of do the angle on it. So what I'd done was, once I decided what the angle was, I milled out a piece of alley plate. And then, I can't do it now because they've got the angles on, but if you imagine these are flat and haven't been milled, you'd lay that on there in the vise, use that as a guide, grip it in the vise, and then run the mill, do that side, run the mill, do that side, and you see there on the flat as well, put it on the flat and mill that. So those three would be the same angle. And then what you do, because you've got the angle on there now, then when you flip it over the other way and sit it on a parallel, parallel like that, you can see now that's level once that's milled. So you mill that level and the same there, mill that level, and then I can't remember how I've done the other one. I may have stuck it in there like that to get that. So that got all the angles on, so that worked well. Also, following recommendations from some of you out there, because I turned up some brass exhaust manifold nuts, I turned up some stainless steel ones, so they're on there now. What was I going to say about turning nuts and flats on the milling machine? If you want to do six-sided, like a nut or a bolt, the way to work it out, another one for engineers, quite at the back, really simple. So you measure your outside diameter, so it doesn't have to be, you know, where the bolt is. It can be any size. So you measure the diameter, and then you measure your spanner to sort of get your width, or measure another nut to get your width that you want to mill down to for your two flats. And then you take that away from your major diameter and then half it, and then that gives you the amount you need to take off. So I use hex blocks, collet hex blocks, to hold these in the milling machine, and it's just a case of you put it in a vise and then bring your tool down and just touch off on the top, then wind in your amount you got to take off, and then do one cut, and then you take your collet block out, turn it over to the next flat, do it again, do it again, do it again, do it 6 times, and then you end up with a bolt or a nut to use. Also had a little field trip out, went to some members of the Hampshire branch of the Riley Register. The Weeks went to their house. They kindly opened their house. They had a little garage sale of spare parts, so I went along there. But I managed to pick up some useful spares. So I picked up a set of rocker assemblies with all the tappet covers and all the tappets in there and the adjusters and everything. So that'll be useful. Also bought an oil pump that had very little wear on it, so I may take the one off I've put on the Riley and put that one on. And then a magneto that's all complete, so it's got the gears with it, it's got the right points plate on it, distributor, the distributor cap and everything on it. Just don't know whether it needs a service or not, but I'll get it I'll get it overhauled, and then I've got a spare. And the other thing I got was a marker light, side light. The ones on a car at sometimes been painted, and it's sort of there's bits of filler everywhere. But I'm not going to do it now. It's a job later down the line. The wings, it's obviously rotted in the usual places, and has had welding works. There's a bit of distortion and stuff. And like I showed you, the front valance panel, I am tackling this at the moment. It's highlighted on there where it's been repaired. It's had a new piece welded, gas welded in there, but it's distorted it all over the place. And as I've said before, it doesn't sit on the chassis properly because it's so bent out of shape. I would easily make a new one if it wasn't for these. It's got these lozenge shapes pressed into it, one each side, that run on the chassis rails that give clearance. There's a couple of rivets on the chassis rail at the top, so it's to give clearance on those. So I was going to put some new metal in, but I think it's sort of seen better days really. So I've got two options, either to make one in steel or make one in aluminium, because sort of, it doesn't really matter as long as it's sort of got etched primer on and painted. Nobody's going to know any different apart from you. And yeah, so I'm just sort of mulling that over at the moment, which way to go on that. But I'd have to make some sort of form up to be able to beat these lozenge shape pressings in down each end. So still mulling that one over at the moment, but I've been doing work on this. The number plate is supported on the front. There's like a piano hinge that is riveted to the front, and then this rod goes all the way through, and they rest one there, but they're all bent. They've been bent so many times, they're sort of, they need replacing. Dog wants to go out. So I wanted to make some steel plates with this sort of roll at the end. And I have sort of watched videos of them knocking it over and sort of making it like this, but I found another bloke that was making hinges on YouTube, good old YouTube, and what he'd done was made a form tool. So I made this, drilled it out, and then with a slitting saw cut it. And then what you do is, because this is quite long, and this is thicker the material than the originals, so the plan is to bend it over at the back as well to double it up, so they'll never bend again. Yeah, and then what you do is, because these are too long, you can thinner material. You could put this in the vise and shorter, and you could just in the vise close the jaws and press it in and round, and then you put a rod through it as it's going round just to keep it in shape. But the trouble is, because this is long, you're trying to press this and it buckles on its length. So what I'd done was you grip the steel plate in the vise with a little bit hanging over, and then pop this on the top like that, and then just leave a little bit of a gap above the vise jaws like that, and then just hammer this down. Just keep hammering it down, and then move the metal up, hammering it down, move it up, and I put a bit of pin in just to sort of help it hold its shape a little bit. And yeah, they come out really well. The only thing is you've got to leave a bit more material, because it's a bit it sometimes doesn't come out quite square. So if you leave a little bit more material, then you can square it off and trim it down, and that'll do the job. But yeah, quite pleased with that. So there we go, progress moving on. So the only thing really holding us up is the vent. I've bought some thread. I've got the vinyl, bought the thread. I'm just debating whether, two minds whether to take the old one apart to get the steel flat bar out and reuse that, or to try and find out what thread pitch it is for the screws that hold the hinges down. But it's a very, very short thread on the screw, so I don't know whether I'll be able to tell what it is, so I might have to take it out. I might be able to, I don't want to take it apart because it's part of the car, but I'm saying that I'll if I'd made a new one, the old one would get shoved in the roof of the garage and sort of forgotten about till the car got sold and somebody else took it on, sort of thing. So I might sort of see if I can undo the stitching at the end and slide it out, so at least I've got the original one there. And then the other thing is, like I showed you, is I've got to try and close that gap up on the between the manifold and the hot air tube manifold. It's had a bit of repair work on there, and gas welding. I don't know whether it's distorted it, but when I got it, it had a blanking plate in place, and whether they'd eased it out and bolted that in, I don't know. So I could sort of jam loads of gaskets in there, but it's not right. I need to sort of try and line it up again. So I might have to sort of cut the tubes off and machine it and tidy it up a bit where it's been welded, and redo the holes and turn some tubes up, put new tubes on. I think that's probably the way I go. It's just that I'm not quite sure how they're fitted in. I suspect they're just a press fit in. Yeah, so it's just something I've got to look at. So once I get that in, I can get the manifolds bolted together, get the carb on, and we're sort of, yeah, exhaust back on. We're sort of getting there, but it's just these little jobs that keep popping up. I'm not, promise you, I'm not going to take anything more apart. Am I? No. Might have to patch the passenger side wing trailing edge up because that has just rusted away, and it was sort of held together with sort of body filler and seam sealer. And the trouble is, where I've been working on it and leaning on it, it's gradually getting worse. So I need to cut it out, but it's easy to get to. So I might just sort of let in a new bit on the bottom for now, just, you know, and keep it tidy, and maybe try and look out for another a better set of wings if somebody's got some out there. I did miss a set ages ago. I wasn't fast enough off the mark to buy them, but they must be out there. So yeah, so there we go, another little update, and we'll see you next time. All right, cheerio. Where's Jenkins, I hear you ask? I haven't seen him for 2 weeks. I sent him down the hardware shop for a long wait, and yeah, he hasn't come back yet. Result. The steering arm that goes from the steering box bloody dog.